Good afternoon, everyone. My name is Nirmal Raj Joshi. I am from Structural Material Laboratory of Saitama University. Today, I want to discuss the result of investigations carried out to measure volumetric change in cementitious material. Today's challenge is to find out ways to make more durable concrete, not only high-strength concrete. Cracking, even micro-cracking of concrete is the main reason for rapid deterioration. This deteriorates the concrete by allowing gas and moisture movement. This also accelerates the corrosion of steel. Shrinkage is one of the factors causing cracking of concrete and causing durability issues. In this study, we tried to study shrinkage mechanism by observing pore-liquid interaction. Concrete is a porous material. If we observe the hydrated cement, we can see that there is unhydrated cement core surrounded by inner products and CHS grain. The pores formed by unused water during hydration is called capillary pores. If we look inside the CHS gel, we can find that there is layered structure which entraps the water. This pore is called gel pores. The CHS layer also contains void in between and it is called interlayer pores. Movement of water in pore causes shrinkage stress in cementitious material. So far, shrinkage mechanism can be explained using three basic theories. The first and the oldest theory is that shrinkage occurs due to change in capillary tension. As we know that there exists negative pore pressure in unsaturated pores resulting in tensile force. If the unsaturated pore is filled with soluble liquids, then tension force disappears and hence recovery may be observed. Another way of explaining the shrinkage mechanism is by the concept of disjoining pressure. According to this theory, the vapor or liquid molecule inside the small pore exerts pressure to the pore, thus maintaining equilibrium. When liquid is added to the material, the new liquid molecule is diffused to these pores, causing a rise in disjoining pressure, and thus recovery may be observed. The third and the last theory to explain shrinkage mechanism is by using the concept of solid surface energy. The dry surface of solid particle has high energy and thus tries to keep its surface as small as possible, thus shrinking. When liquid is added to such unsaturated or dry surface, liquid molecule is adsorbed in the surface and some energy is released. The creation of interfacial surface between the solid and liquid may cause shrinkage recovery. In this study, what we want to do is observe the volumetric or shrinkage and swelling behavior of specimen when it is soaked in different liquids like water and DMSO. This is the setup for experiment. It consists of displacement transducer which senses the change in displacement up to 1 micrometer and this value is recorded by data logger. Temperature and humidity were also recorded during the experiment. Here we can see the actual equipments used for experiment. The test sample consists of two parts. The first one is 7 days old cement paste and second one is ALC samples that were taken from commercially available source. In addition, a quartz glass was also used to correct the deformation due to temperature variation. Similarly, water and DMSO was used as soaking liquids. You may ask why we chose ALC and why DMSO. ALC stands for autoclave lightweight concrete. This material is now widely used in construction, especially for purpose of heat and sound insulation. ALC is highly porous and has more volume of larger pores as can be seen in the graph. Similarly, DMSO was used as saturating liquid because it has similar properties to water like viscosity and polarity and it readily dissolves in water. During experiment, we took saturated sample and then dried it in a climate control room for 24 hours and then the samples were soaked in liquid and deformation was recorded for 24 hours. After that, for next 24 hours, samples were re-dried. All deformation values, temperature and humidity were recorded at interval of 5 minutes during the experiment. This graph shows the result of experiment using ALC sample. As said earlier, the saturated sample was dried in a specific environment for 24 hours and then soaked in liquid for 24 hours and then re-dried for next 24 hours. The general trend was that the sample soaked in DMSO showed recovery of shrinkage. The drying condition did not affect the shrinkage recovery. In case of sample soaked in water, shrinkage did not recover but remained in constant value, and when the sample was re-dried, shrinkage continued. This is similar graph for cement paste sample. Here you can see that recovery from DMSO and water is almost same. But while re-drying, sample soaked in DMSO did not re-shrink, but the sample soaked in water started to shrink again. The possible explanation for such shrinkage behavior can be explained as follows. The capillary tension force in unsaturated pores may have disappeared when filled with DMSO. Similarly, we can argue that addition of DMSO increased the disjoining pressure in pores and thus recovery may have occurred. After collecting large number of data, we wanted to verify our data. To verify the data obtained from displacement transducer, we used strain gauge to measure shrinkage strain in ALC sample. This graph shows the shrinkage values obtained using strain gauge. It shows that shrinkage is recovered when the sample is soaked in water. The above graph is in contrary with the shrinkage value obtained from displacement transducer. In the blue graph, we see that shrinkage is recovered, while in the orange graph we see that shrinkage did not recover. Thus the results were not concluding. So why did the discrepancy happen? It may be that when liquid is poured displacement sensor, it could have recorded the sudden expansion data giving some faulty readings, but we are not sure that which of the shrinkage value are correct till date. Similarly, we could not verify the DMSO because the adhesive of strain gauge was dissolved in DMSO. I want to conclude this talk, so let's summarize. In this experiment, shrinkage was measured using two methods. Each method gave quite different results, so we could not verify the shrinkage behavior mechanism, and thus we are searching new method to verify the shrinkage behavior. Thank you very much.